Algebra 3, Lesson 2, you can look in your book and you're going to see some things. The lesson effectively boils down to area, dealing with cylinders and prisms, cones and pyramids, and spheres. So some of this stuff was stuff that is covered in geometry, but it's not even covered until, probably closer to semester, if not second semester type stuff. So it's going to involve some formulas, things of that nature. One of my recommendations on finding finding the information that you need in your book is looking for the bolded words and definitions in your book. So some of the things that you'll see that are bolded in here on page 14, we define the area of a rectangle to be the number that equals the product of the length and the width. That one you should know. Right, Algebra 1 kids know that rectangles equal length times width. Okay, nothing new there. Area of a triangle. Who can tell me what the formula for the area of a triangle is? We actually use 2, but go ahead. Base times height divided by 2. That's my favorite because I don't like multiplying by 1/2. Right, ultimately I'm dividing by 2. All right, so you need to know the area of and that is really pretty well true for a lot of this. I know it says area of a right triangle. But we can use even that to find the area of some triangles that aren't right. Let's see, you can flip the page over. It's going to talk about cylindrical surfaces, parallel planes, oblique cylinders. Effectively, one of the things you want to know about finding the volume of a cylinder is it's the area of the base polygon times the true height of it. So if it's an oblique cylinder, it's the true height. So imagine you're trying to find the volume of the Leaning Tower of Pisa. It's not how tall the slant height is, it's how tall the altitude is from top to bottom. Okay? So you see some formulas in there. You got cones and pyramids that show up on page 19, volume of a cone or pyramid. It works on the same premise. With a cone and a pyramid, it's based upon the idea of a prism or a cylinder, but we're dividing that by 3, okay, because we're coming up to a point. So let's say we've got a pyramid, it's area of the base polygon, except in this case it's length times width, right, because the base is a rectangle or a square, all right, times the height divided by 3. Same thing is true of a cone, of a cone. It's based upon a cylinder, area of the base polygon. The base polygon of a cylinder is pi r squared because the base is always a circle. The area of the circle is pi r squared times the height, and if it's a cone, we divide it by 3. Okay, so we can draw some of these things up here on the board as we begin to answer some of these questions. But if you notice at the bottom of page 19, we'll deal with more complicated types of pyramids or even cones where it's dealing with a very complicated base. But the premise is still the same. We have to find the area of that base, then find the height, multiply those things, and in the end, I'm still dividing by 3. Okay? You can go on. You'll find surface area. Surface area isn't going to include the base of the pyramid or the cone. If we're talking about actually, no, a surface area will include it. It's lateral area that doesn't include the base. Okay, so you're dealing with everything except the base, and we'll draw up some of that stuff. But all of these formulas are found in your book. It's a rather long deal. Over on page 22, important things you want to know are with spheres, the surface area of a sphere is 4 pi r squared. Volume of a sphere is 4/3 pi r cubed. Okay, because we're talking about volume. Volume is always cubed because we're dealing with something that's in 3 dimensions. Area is 2-dimensional, so it's squared, 2 to the second. When you start dealing with hemispheres, it changes a little bit. I want to say that the surface area of a hemisphere, if you include the base, is 3 pi r squared. All right, so there's a lot of information here. I don't want to spend the bulk of time covering things that you already know. Some of you already know and some of you don't. I'd rather go ahead and start in by answering some questions and find out by answering questions what it is that you know and what it is that you don't know. This says find the area of a triangle. Again, finding the area of a triangle is base times height divided by 2. All right, you guys should have this. sent to you already, so you can see some of these numbers. Even if you can't see them on the board, you should be able to see them. All right. What is the base of this triangle, Emmanuel? Number 1. What's the base?
The actual triangle or the added part too?
Well, you don't have the added part. 14. Okay, so base is 14. What's the height? Perla, what's the height of that triangle? 10. Okay. Notice that she did not say 12. The true height, the altitude, the distance from top to bottom. And so the definition for height in this case, or altitude, is the distance that goes from one vertex to the opposite side but remains perpendicular. Okay? 12 is not a perpendicular line. So what we have is 14 times 10 divided by 2, because we're multiplying by 10. What's 14 times 10? 140 divided by 2, 70. So 70 feet what? Squared. Okay, well, you're just answering a question, or did you have a question? Okay. All right, do we understand this so far? Okay. If you're Michael's scratching his nose or something, or scratching his teeth and shaking his head, no, I was confused. All right, 70 feet squared. You got it? Good. All right. This works on the same principle, right? Michael, what's the base of that triangle?
32.
What's the height of it? 11. So we're going to take 32 times 11 and then do what with it? Divide it by 2, because we want the area. So what's 32 times 11? And you could do that. There's maybe even an easier way to kind of think about this. I know I'm going to end up dividing by 2, so what I could do is I could take 32 divided by 2 and multiply that by 11. 32 divided by 2 is 16. 16 times 11. In any case, I should get what? 176 feet squared. Okay? If you get to a question that you struggle with or you need more time with before I move on, please raise your hand. If you need to see work for something that I just said out loud, right, please stop me. We'll go back. I'll actually write it down. So, like I said, I don't always know what it is that you don't know. So help me out by getting me to slow down or stop. Surface area of a right circular cone. Okay, notice that in all of this, does anybody see a picture that goes with number 3? No. Okay, that complicates things. Either 1, I need to know the formula, or 2, I need to be able to draw it so I can get an understanding of it. So it's a right circular cone. It's not oblique, nothing like that. So I'm going to draw something like this. Right circular cone. Okay, should come down. Should look like that. I haven't even put any information in yet. Okay, surface area. Is that going to include the area of the base? Yes. Okay, so I know that part of this area is going to be what? What formula? If I'm going to include the base, what's the pi r? No. Well, yes, that's in it, but pi r squared is going to give me the area of the base, right? And then if I want the rest of it, that's pi rl, correct? So that's the formula for the surface area of a cone. If you don't know that, you need to write it down. It needs to be in your notes. Not that I'm going to go back and make sure that it's there, but you need it for you, okay? Because I'll say this about this textbook. It is not to go back and find things. So if you don't know this formula, you need to write it down. Okay, so surface area of a right circular cone whose slant height is 16. So we're going to put 16. We got pi 16, whose base has a radius of 5. Okay, so pi 5 squared plus pi times 5 times 16. Okay, I'm going to give you my own recommendation on this, is that I wouldn't type in my calculator pi 5 squared plus pi. I mean, you can do that and you'll probably even get the right answer. But for my own personal sake, I'm going to solve in terms of pi until I'm down to just a number and pi. So I know that I have 25 pi plus whatever 5 times 16 is, which is 80. So I got 25 pi plus 80 pi. Are those like terms?
Yes.
Yeah, and if I add them up, I get 105 pi, right? Okay, 105 pi inches squared. If I wanted to, I could go ahead and put that in as a decimal, right? But for now, 105 pi inches squared is an exact answer. In fact, it's more exact than if I were to plug pi into the calculator and hit enter and get a big long decimal. 105 pi inches squared. Okay, number 4 is the same question with different numbers. In fact, they give you the same radius, so there's really only one thing to change, and that is to swap 16 out with 15. So what I'm going to do at this point is I'm going to hit pause on the video. I'm going to let you guys solve that, get your answer back to me, and then we'll move on to number 5. Okay? All right. What answer did we get for this? I want your answer in terms of pi. Let's see. Somebody besides David. Michael, what'd you get? 100 pi inches squared. Very good. 100 pi inches squared. Did anybody get something different than that? Everybody got 100 pi inches squared? Very good. Okay. Number 5. We're halfway, well, kind of halfway through. Volume of the pyramid. So this is area of the base polygon times the height divided by what? No. When we're talking about pyramids and cones, we're dividing by 3. Okay? So the volume of the pyramid. We want the volume of the pyramid. All right. So if I want to find, this is my base. This is what they're showing me up here top. This is the base. I need to find the area of that. Okay? I'm going to kind of cheat here, but do you notice anything about the triangles on either end? They're congruent to each other. Triangles that are congruent make a what? In this case, they make a square or a rectangle, right? But in this case, they make a square because the base is 2 and the height is 2, right? So because of the area formula of a triangle, it would be base times height divided by 2, right? So 2 times 2 is 4, divided by 2 is 2. And then I would do that again, right? So I would get 2 times 2 divided by 2 and get 2, and then I would add those together and get 4. Essentially what I've got here is a square, though, where I'm getting 4, right? 2 times 2 is 4. And then I have 3 times 2, right? So I'm just taking these and I'm adding areas. 3 by 2 is 6. 6 plus 4 is 10. So the area of the base polygon is 10 meters squared. Does that make sense? Yes, so far? All right, so area of the base polygon, base times height divided by 3. All right, what's the height? 3. Look, altitude is 3. Okay, so they tell me it's 3. So I've got 10 times 3 divided by 3. Well, what's 10 times 3?
30.
30 divided by 3?
10.
3's cancel out. I get 10 meters cubed. Okay, that one was really, really easy, right? Okay, for the most part. Okay, base times height divided by 3. That big B stands for area of the base polygon. If I understand what that means, then I'm going to use that for a cone, except in a cone, that B stands for pi r squared. All right, moving on. Okay, 6. Same thing, different numbers. So I'm going to hit pause. I'm going to let you guys work this out on your. All right, let's go ahead and talk about this. What was the area of my base polygon? Does anybody know?
25.
25. All right, you had 3 times 5 is 15, and then you had it again on the other side, right? So that means that I'm dealing with a rectangle, correct? So it's just 15. And then 2 times 5 is 10, so 15 and 10 is 25. So you have a base there of 25. What am I multiplying that by? The height of 4. What's 25 times 4? 100. Okay? And then I'm dividing that by... Anybody hear that? Okay. It's 100 divided by 3, which, based upon the nature of it, is going to end up reducing to 33 1/3 feet cubes. When you do that in your calculator, you're going to get 33 point, is it 3 repeating? And if you hopefully you're familiar enough by now to know if it's 0.3 repeating, it's 1/3. All right, if it's 0.6 repeating, does anybody know what that is as a fraction? 2/3. Okay, so we've got that. I've got about 3 minutes before I want to stop and let you guys work. So the rest of these sphere, 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 and then on 10, we've got a pretty complicated question. So hopefully we're familiar with how to find volume and surface area. Okay, this is giving me the radius, so that's pretty easy. I'm just plugging it into those two separate equations, 4 pi r squared and 4/3 pi r cubed. Can we do that? Do I need to help you out there? Let me do this for you. I will go ahead and I'll give you the answers for number 7. Still sounds like some of these stuff is going on. Number 7, your surface area is 16 pi centimeters squared. Your volume is 10 2/3 pi centimeters cubed. Number 8 is fairly similar, same type of thing. You should get a surface area of 676 pi feet squared. If you're not writing this down, you probably ought to, just so that you can, if you ever have to go back and look at something, you can at least double check and then ask me, hey, this is what you got on that stuff the other day. I don't know how to get that. And then on 8, your volume should be 2,929 1/3 pi feet cubed. What is that? What on earth is that? It's like Mexican music. Does somebody have their phone on? Somebody's got their stuff on. You need to turn it off. All right, let's do this. Let's come down to number 10 because we're chewing up time. It's going to drive me nuts. All right, so it says that a satellite is in the shape of a cylinder that has 2 hemispheres fitted on either end. Okay, so what it looks like is it looks like a giant pill, right? You have ever seen a pill that's kind of cylindrical in nature, but it's curved around the edges. All right, fitting snugly on either end. If the diameter of the cylinder, that'll throw you, okay? Because when we're talking about cylinders, what do we work with? Radius, okay, is 4 meters. So I need to probably go ahead and change this to 2 meters for my equations, right? All right, and its length is 14 meters. So, and that's going to be true of the hemispheres that are on either end. We want to find the volume of the satellite, express your answer in terms of pi. Here's the interesting thing about it. If I have 2 identical hemispheres on either end, if I took those off and put them together, what would I have? I would have, no, 1 sphere, right? So really what I'm doing is I'm taking a cylinder plus a sphere, right? So what I can do is I can say, 4/3 pi r cubed plus pi r squared times height, because this is how I find the volume of a cylinder, right? Area of the base polygon times the height. The base polygon of a cylinder is pi r squared times the height. So now the only number that I'm going to use 14 for the height of the cylinder, and I'm going to use 4 for the radius for everything else, right? Oh, I'm sorry, 2, because we're, okay? So we have 4/3 pi, 2 cubed, plus pi, 2 squared times 14. Does all that make sense? I know I'm going through it really quick. 2 cubed is 8. Okay, 8 times 4. 8 times 4, 32. What's 32? Oh, 32 divided by 3. I don't know if I know that one. Okay, so 10 2/3, right? 10 2/3 pi. Over here I've got 4 times 14. We're going to have, what, 28, 56 plus 56 pi. So that would give me, what, 66 2/3 pi meters cubed. 66 2/3 pi meters cubed is the answer. Does that make sense? I know I went through that really quick. Is anybody missing anything that you would normally need from that? Now, that would be a little bit more complicated. What if I only had a hemisphere on one end and didn't have, I'd end up having to take that 4/3 pi r cubed and dividing it by 2. Okay? So I believe I'd have to look at that, and because I mean, we can simplify that down, but I'm trying to remember what it is. I don't remember off the top of my head. So anyway, we're going to stop with that. I went about 2 minutes over what I wanted to, but you guys should still have time to work. Okay?